Welcome to ClickMyProject.com. Now we are going to discuss about the project Parkinson's disease detection based on running speech data from phone calls. Now we are going to discuss about the abstract of the process. Parkinson's disease is the second most common long-term chronic, progressive and neurodegenerative diseases affecting most of the 10 million people in the worldwide. This process is mainly aimed to utilize the pre-trained classification structure and conventional machine learning models as a semi-automated approach to diagnose the Parkinson's disease from the voice signals. We have stacked the extracted features from the deep learning methods, including the MFCC, to generate the discriminative feature vector. Then the feature vector are classified by means of the machine learning algorithm to classify whether the person is having the Parkinson's diseases or else the person is the normal speech. The result of the process is evaluated by means of the accuracy, sensitivity, specificity, precision and recall. By using these three parameters, we can justify our process is efficient or not. Hence, this process is mainly objected to do the Parkinson's disease diagnosis method. Now we are going to discuss about the overall working flow of this process. This is the overall working flow present in this project. The module consists of input data, pre-processing, feature extraction, classification and finally performance estimation. These are the modules we have done in this project. At first, the input data is taken from the dataset. The dataset consists of lot of data which having the Excel file format, which having the speech signal formats. After extracting some data from the dataset, we just go for the next stage of the project, that is the pre-processing. So in this pre-processing, we have two kinds of pre-processing methods is there. One is signal limitation, then another one is the signal normalization. So signal limitation is done to, if the number of features is high, means it will consider the signal limitation to restrict the length of the signal. After that, normalization is carried out to enhance the quality of the signals. After doing these two techniques, we just move to the feature extraction. So in this feature extraction, we have applied the two things. One is the MFCC method, then peaks method. So after extracting these two features from the signals, we just move to the fourth stage of the project, that is the classification. This classification stage, we have applying the k nearest neighbor classifier, that is the kind of machine learning classifier, to classify whether the person is having the Parkinson's diseases or else the healthy person. After doing the classification, we just do the performance estimation by means of the accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B, then change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the new user interface will be open. In that user interface, you can click the button input data. After clicking the button input data, we have to select the dataset in the name of dataset. So after the selection of the dataset from the folder, the selected dataset will be loaded automatically. Then it will displayed in the table 1. This table 1 is the raw data we have selected from the XLS file. You can see the several attributes as well as the several patient data like this. We have around 167 patient details here. So after fetching the information from the dataset, we just move to the second stage of the project, that is the pre-processing. In this pre-processing, it will load the raw data and then it will convert the data into one signal format. You can see the difference between this one. So the table 1 represents the values as well as the coefficients of the signal. This figure represents the signal values. After generating the signal, we just move to the feature extraction. So after doing the feature extraction, we have to extract the features. Now I am entering the features 4. Now the fourth person features will be extracted here. You can see the difference of the values here. So this is the train set, this is the test set. This is the test set we have extracted here. The input selected data signal is separately plotted like this. After doing the feature extraction, we just move to the classification stage. In this classification stage, it will classify whether the input person is having the Parkinson disease or not. So it will classify like this. Then the corresponding result will be shown in this message column. After doing the classification, we just move to the performance estimation. So in this performance estimation, we have estimated the performance like accuracy, sensitivity, specificity, precision and recall. The bar chart represents the values of the accuracy, sensitivity, specificity, precision, recall. The corresponding values are shown below. So these are the values we have achieved from this classification method. Thanks for watching this video.